Let's get into this, our first quantitative problem in this chapter. We're not going to do a whole lot of quantitative information, but I do want you to be able to do calculations such as this. Okay, silver crystallizes in a face-centered cubic arrangement. So reminder, that's FCC. And it has a lattice constant of 4.07 angstrom. Calculate the density of metallic silver in units of grams per milliliter. Okay, so just as a reminder, we remember FCC. Let's just think about what all this stuff is going on. So this lattice constant of 4.07 angstrom, that's the length of our cube. Okay, so just pointing that out. And then what we also need to remember from FCC is that it's 4 atoms per unit cell. That's something I want you to know. I want you to know that SC is 1 atom per unit cell, BCC is 2 atoms per unit cell, and FCC is 4 atoms per unit cell. Okay? And so what we need to calculate this now is the mass of 4 silver atoms divided by the volume of our unit cell. And it's asking us to do this in grams per milliliter. So we want this to be grams on the top. And I'm actually going to calculate this in units of cubic centimeters, which we recognize is the same thing as a milliliter. Okay? So let's go for that. So first we're going to calculate the mass of 4 silver atoms. So this should be a nice stroll down memory lane doing our Gen Chem, or our Chem 109 type stuff. So first I want to use Avogadro's number. So 4 atoms, and I'm going to put down at the bottom 6.022 times 10 to the 23 atoms in 1 mole. We also need to know the mass of a single silver atom, and I don't have my periodic table in front of me here, but I've got that written down. We know 1 mole of silver atoms is 107 I think that says 9 on my notes. 107.9 grams. And so now we can do that calculation. So that's going to be 4 divided by 6.022 e to the 23 equals. And then now I'm going to say times 107.9. And yes, that looks good. I get, I'm just going to put a whole bunch of sig figs on this thing, and then I'll estimate them at the end. So I get 7.167, we'll say 1, times 10 to the minus 22 grams. Okay, now I need to calculate the volume of my unit cell. And because it's a cube, that's simply just going to be this number here, L cubed. Okay, I just have to cube that number, and that's going to give me the right volume. Okay, and I want to convert it into centimeters. All right, so here's what I'm going to do first is go 4.07 angstrom. Here, I give you the angstrom unit. I don't expect you to have an angstrom memorized. For those of you that do chemistry as a major, you probably will learn the angstrom by heart. So in 1 angstrom, there is 1 times 10 to the minus 10 meters, as this says here. But now I'm going to include another step, and I'm going to say in 1 meter, there's 100 centimeters. And I want to convert this into centimeters because if I cube it, if I cube a centimeter, I get a cubic centimeter, which is the exact same thing as a milliliter. Okay. So when we do all of this, 1 times 10 to the minus 10 times 100 is the same as 1 times 10 to the minus 8. So directly, I can just say this is 4.07 times 10 to the minus 8 centimeters. If you don't see that in your head, use the calculator. Convince yourself you know how to get here. Okay, and now all I need to do is cube it, And we remember when I cube something, not only do I cube the number, I cube the unit. So now that's 4.07 times 10 to the minus 8. And now I'm going to say cube it. Okay, so now I get 6.7419 times 10 to the minus 23 cubic centimeters. So now I have a mass, I have a volume. Both of these numbers look crazy small, but remember, we're talking about one singular unit cell. So that is a very small thing. And then now I'm going to divide these two numbers to get the density, minus 22 grams, all over 6.7419 times 10 to the minus 23 cubic centimeters. And so now let's do that math. So 7.1671 times 10 to the minus 22 divided by 6.7419 times 10 to the minus 23. And look at that, I get 10. And now here's where we'll apply our sig figs. So this says 10.63, but the only number I had was from the unit cell dimension, the 4.07. So that's 3 sig figs. So now I'm going to call this final answer 10.6 grams per milliliter. And in fact, if we were to look up the density of silver, we would find that it's 10.6 grams per milliliter. This is really cool. So when we think about this, just to wrap your head around this, right? In our solids specifically, okay, we can shrink ourselves down to the size of an atom, right? And have this like singular unit cell. And the density of that unit cell is exactly the same if we had one of them or if we had 1 mole of them. Think about that. If I had 1 mole of these unit cells, it would have the same density as if I just had one of them, which is so cool, I think. Okay. So we're going to do several more types of calculations like this during our live meeting, but this is kind of the basic gist of it.